And then default values versus local variables, like we have discussed already multiple times. So for instances and static variables, those are having default values, and those are 0, 0 for int byte, an int gets 0, a double gets a 0.0, a boolean gets false, and object reference gets null. You don't need to write 0 for instance variable. Java does it behind the scenes. Those are by default, right? Even for static variable. Rule number 2 is that local variable gets nothing. If you declare int bonus inside a method and try to use it without assigning a value, the compiler gives you an error. We have discussed it. And even here also, if you see here, so these two are, one is static int count, int score, and then we are using these two this is static variable, this is instance variable. Both we are using here without any problem, right? But if you are declaring a local variable here, trying to use it, that will lead to compile error. Typecasting overview. Typecasting is the process of converting one primitive data type into another. Java supports two types of primitive typecasting. So basically smaller to larger, right? That's called widening, and larger to smaller is called narrowing. So going from a larger type to smaller type is called narrowing and explicit casting. You must manually tell Java to do it because data might be lost. So, and smaller to larger type is called widening or implicit casting. Java does it automatically because there is no risk of losing data. The widening path goes like from byte to short to int to long to float and double. You have to remember that. Okay, byte to short to int to long, float to double, and char fits into int. So moving right is automatic, moving left requires a cast. So if you are moving from byte to short to int to long to float or to double, so that's by default Java will do it. But if you want to move from say float to long or long to int, you have to cast it. Example is you can have int x is equal to 10 and double d is equal to x, right? So if you are say doing that, and that will be automatic. You are having an int value is equal to 10 and you are putting it to a double variable, so that's fine. But narrowing is that if you are having a double variable here and you are trying to put that into an int value, in that case it will not work. Otherwise it will be a compiler error. What we have to do is that before putting it into the int variable, you have to cast using within bracket int with the double variable, right? So that we have to, that's called casting. So one exam tip is narrowing casting may cause precision loss and must always be done explicitly with a cast operator. So implicit casting and widening, smaller to larger, like we have discussed earlier. So let's see the first example. Int x is equal to 100 and long y is equal to x. So we are assigning x to long y, so it's widening. And then x, then we have double z is equal to y, right? So all these things are widening, int to long and then long to double. Same with char value we have within quotes a, and then same value we are assigning to int x, and char to int is automatic. That's also fine. And then we have byte to int to double. These are all widening. We have to remember that. Now let's come to explicit casting or narrowing. So you see that you are trying to, in the first example, we are trying to assign a double value to an int, right? That's so we have to, it's narrowing. So we have to do the explicit casting here to make it int here. Same with the next example, int I and byte b, right? So in this case also int is much larger and we are trying to narrow it down to a byte. So we have to explicitly cast it. But we have to understand one thing about this particular casting. It's called overflow. We are going to discuss a little more. So in case of byte has a range of -127 to plus -128 to plus 127. So but this value is 130, right? That's so it's bigger than what a byte can hold. In that case, what will happen is that byte can hold till 127, but this is more, so that's why it will cause a problem. So what will happen, something called overflow will happen. So what you have to find this value, what you have to do is that in such cases that 130 minus 256, that is 126 overflow. So then byte's value will be 126 here, not 130, and it will be minus. Int x is equal to 65, and then char c, we are again char is smaller than int, right? So we are downcasting it or narrowing it, and so after narrowing, c will be a, because 65 belongs to a. And without the cast, if you don't cast it right, double you are putting it here, it will be a compiler error. So here let's discuss about overflow, right? Let me explain what happens when 130 gets cast to a byte, right? We were discussing it. So byte is 8 bits. It can hold values from -128 to 120 plus 127. That's a total of 256 possible values. Think of it like a circular clock with 256 positions instead of 12. The quick formula is, if you need it on the exam, take the value, divide by 256, get the remainder, and if it's above 127, subtract 256. So 130 remainder is 130, so it's above 127. So 130 minus 256 equals minus 126. That's your answer. So when you cast 130, Java takes the value 130 and wraps it around this 256 circle. So 130 is bigger than 127, right? So you just so what will happen? The overflow will happen. The math is simple. Take 130 divided by 256 and look at the remainder. So remainder in this case is 130 only, right? Because you are dividing 130 by 256. So since the bytes positive range stops at 127, anything above 127, so 130 is greater than 127, right? So it will wrap into the negative side. So 128 becomes 1 minus 128, minus 129 becomes minus 127, and then 130 becomes minus 126, right? So at 127 the byte is full, right? So it will print 127, that's fine. But 128, what happens? There's an overflow, right? So you have to just the number minus 256. So 128 minus 256 is minus 128. Then 129 minus 256 is equal to minus 127. Overflow is happening here, right? Because greater than 127. Same here, 130 minus 256 is 126. Then this also 255, right? So 255 is greater than 127, and then also remainder is 255. So 255 minus 256 is equal to minus 1, right? That's the value. And if you are having 256, 0, right? That minus these things. And you are having 257. In that case, you have a remainder of 1 and 1 stays here, right? Let's move to the next slide. Common casting compile time errors. So error 1 is int x is equal to 10.5. 10.5 is double by default. You are assigning it in an int without a cast, compilation error. You need to need int x, then you have to cast it to int using bracket int or just write int. You need int x is equal to, you have to downcast it within bracket int 10.5, okay? Or just write int x is equal to 10, not 10.5, that will work. Error 2, so long, big, right? We have discussed this is too big a number, and you are not putting an L there. That number is too large for an int literal, right? But by default it's int, all values are treated as int, so you need to put L suffix there, because int cannot hold such a big number, 1 into 1 then 10 zeros, it won't be able to hold. So you have to tell the compiler, okay, it's not an int, it's a long values, we are putting an L suffix there. Same goes with float, that for float f is equal to 3.4, but 3.4 is a double by default, so you have to tell the compiler that 3.4 is double, so it will need the f suffix, right? You have to put f suffix there. And then boolean b, in Java boolean value can hold only false or true, and so it just cannot have a 1 here, right? In other languages you probably can have 1, but in Java is true or false only, right? So you just cannot have a boolean b is equal to 1, so it's incompatible, so that will be one compiler error there. The other thing is that true or false, right? It has to be in small case. If you are putting in true or false in caps, that's a separate value altogether. So that becomes a variable name, right? Capital, if you are, so it has to be in small case. So Java only recognizes lowercase true and false as boolean values. True in caps is not a boolean literal, is just a regular identifier, okay? Question 1 is byte b is equal to 127 b plus plus. Now b plus plus makes byte b is equal to 128, right? So that's byte cannot hold, so overflow will happen. So what will be the value? 128 will be, answer will be b, right? 128 minus 256 is equal to minus 128. That's the value. And the question number 2 is mixed casting and literals for the area a, b. So int a, this is int is equal to 10, then long b is equal to a, then float c and double d. So as you see, these are what is happening is that these are normal widening only, right? So widening, so it's all fine, right? It will compile, and once you do the system out that println, it will be what value? All the first will be 10, then it will be again 10, then but float is 10.0, right? And double is 10.0. So 10.0, so it will print 10, 10, 10.0, 10.0. So answer will be D. Okay. Okay. So next we are going to meet you in the next video. Have a good day.